Today we're going to be looking at circles once again, but this time we're going to be looking at them on a graph, and I think this will also help you as you prepare to go into Algebra 2 as you move on in your math life. So let's take a look at some circles on a graph. Let's start with the most simple circle. This is called the unit circle. It has the center at 0, 0. Okay, so we have a center right here. There's two parts that really define a circle, the center and the radius. And this one happens to have a radius of 1. I'll put r equals 1. And then the equation for this circle, if you were to actually want to type this out and get it on Desmos, is x squared plus y squared is equal to 1. And what that does is it essentially allows you to graph this circle with a radius of 1 and a center of 0, 0. But that's not exciting enough. We need to move this circle around. What if we wanted it to be bigger? What are the rules? I've never seen an equation like this. Well, let's talk about it. So let's move to a more general case. Let's say that the center is still at 0, 0. That'll keep things simple for now. But this time instead, let's make the radius any number greater than 0. So the radius could be anything besides negative numbers or 0. So 1, 2, 3, 4, 5. In this case, in my example here, my radius is 5. So just showing that you could actually do that. The general equation for these types of circles are pretty similar. X squared plus y squared equals r squared. Okay, in the example I gave above, the radius was 5, and if we take 5 squared, that's just 25. So this would be the equation for my example that's graphed to the left there. Okay, notice that the left half of the equation did not change at all, and that's mostly because the center is still at 0, 0. What we're going to do next is take a look at how you can move a circle around on the graph itself, not just make it bigger or smaller. So let's try that. The equation of a circle with a radius r and a center at the coordinate h comma k, where r is any number greater than 0, is this equation. Notice that it looks a little bit different than our original equation. These h and k terms determine where the center is. So for example, if I wanted my center at 0, 0, I would have to make h0 and k0, which makes it simplify out to what we saw just a moment ago. Okay, so if h and k are both 0, these just basically go away. We get x squared plus y squared equals r squared. Okay, if you have any other number besides 0 for h and k, you're going to have a different center for your circle. Let's look at some examples. Okay, first example, x minus 1 squared plus y squared equals 4 squared. Now, we want this example to match what we have over here. And in order to do that, we have to say, okay, I have x minus 1 squared. That tells me what h is. H has to be 1. Okay, plus, let's try writing it, y minus something squared. And the something that goes here has to be 0. Okay, I know we usually wouldn't write this, but in this case it's helpful to think about it that way, because that way we can just understand k is actually just 0. And remember, that's our center at hk. Okay, and that equals 4. Okay, now from the equation, 4 was equal to r squared. So r squared equals 4, which means r has to be 2. And really, when you're doing these problems, these are the three things you're looking for: the center with h and k, and then the radius. Okay, so now we can write the equation. This would just be, well, I mean, the equation's already written. We can move on from this. This is the equation, essentially. I'm just identifying the center and radius. In this case, we come across something a little bit tricky. I know that the equation is supposed to look like this. Oops. Okay, so we can get a few things right off the bat. For example, y minus 5 is y minus k. We can just quickly deduce k has to be 5. We can also find out that r squared is 1. R squared equals 1. The square root of 1 is just 1. So we have those two pieces of key information there and there. We still need to find out h though, and the problem is we don't have it written like we want it to. We have x plus 1 squared. The way to think about this is we need to rewrite it so that way it'll equal the same thing, but at the same time we can figure out exactly what h is. Okay, because it has to be in this minus form. If we do not have this minus sign, it's so crucial in finding out these things. There are a lot of ways to guess and prove yourself right on these problems, but I'll get to that in a second through Desmos. In this case, x plus 1 is the same thing as x minus negative 1. Two negatives make a positive. Okay, so we have x minus negative 1, which means that h has to be negative 1. So in this case, it wasn't as easy as just plugging in the number that comes after the minus sign. If you have a plus sign, you have to switch the sign of h and k, whichever one it might be. So here we have a center, I'll just put a C, center at h comma k. H comma k is negative 1 comma 5. And I'll put where I got those numbers, h comma k. And the radius is going to be equal to 1. Okay, let's do one more example before we talk about what the delta math is about. Let's see. Okay, first of all, I can see some direct similarities. It's always helpful to have some scratch paper when you're doing these problems. I find that just writing out the standard form for a circle is super important because you can make direct links. In this case, x minus 3 squared, h has to be 3. Y plus 3 squared, remember that that's the same as y minus negative 3 squared. So k is equal to negative 3. So we got that part. And now I see that r squared is equal to 36. Okay, if you remember our perfect squares, the square root of 36 is just 6. So in this case, yes, we are square rooting both sides. Okay, but it will be a whole number for this assignment. So we got our three parts, h, k, and r. Let's just write down where the center is. 3 comma negative 3, that's h and k. And then r, my radius, is going to be equal to 6. Okay, now what I've done for you guys in the link in the description below is I've included this this Desmos graph that can help you solve these problems. Here you can see this is the formula I've been using for those last three examples. And here you can see that I actually included sliders for h, k, and r. So for example, if you wanted a circle with radius 2, you can plot that. You can have a circle of any radius up to 12. You can move k around. Remember, k is tied to that y coordinate. It moves it up and down. Okay. And h is tied to your x coordinate. So if you're unsure what h, k, and r are, you can go to this Desmos graph and plug in different numbers and see if it matches the one on delta math. Speaking of delta math, let's get back to some examples. So you'll find these problems on the delta math assignment itself. This is question number 1 right here. So if you pay attention now, it's a free question. Anyways, as I do often enough, determine the equation of the circle graphed below. I know what the equation needs to look like. Has to look like that. So essentially we need to figure out h, k, and r and then write the equation out, plug that into delta math, and we should be fine. Okay, first thing you'll notice is, well, it's helpful to zoom in a little bit. If you go onto Chrome and you click on the 3 dots on the top right corner, you can essentially zoom in to the screen on Delta Math. Here I'm zooming in with my fingers. I just clipped this out of Delta Math itself. But what you'll notice is you can count squares here, which is useful. First thing I'll notice is this has to be the center, as is defined as equidistant from all the points. So here we have a center that is the same distance from all the other points. My center is at a coordinate 2, 4, which means two things. I know what h is, and I know what k is. H has to be 2, and k has to be 4. So just by looking at the coordinate of the center, I already have 2 of the 3 pieces that I need to write the equation. Piece number 3 is just the radius. In this case, it turns out to be quite simple. The radius is just 2 units long. Okay, so I'll put radius is 2, but for my equation, I need r squared. So instead, I'm going to keep going. I'm not going to underline this yet. R squared equals 4, and there. These will be my 3 pieces that I'll use to construct my equation. I'll plug in the numbers here, here, and here. Let's see. The equation will be x minus h squared, which is 2, y minus k squared, which is 4, is equal to r squared, which is 4. Okay, now I'm going to show you how to enter that into Delta Math itself, just in case you're new to Delta Math or you're not sure you understand all the math tools. Okay, here we are on that same problem. Let's see. I'm going to enter my answer in here, and what you'll notice is, well, I don't even have a keyboard. So luckily there's this nice keyboard button right here, and what this does is it unlocks all of the math calculator parts. So we have parentheses, which we need to type in x minus, what was it, 2? Okay, and this button squares things, so that I'll square that whole term, plus another parentheses. See, y minus 4, end parentheses, hit the square button again, and that'll be equal to the radius squared, which is 2 squared, which is 4. So when I submit this, answer should be correct. Please. Okay, it was good. We're good. So that's how you enter in the problems. I'm not going to go back for every example to show you how to do that. Okay, let's move on to one that's a little bit more interesting. Well, it's bigger. A lot harder to find the radius here, but there are some things you can notice. First of all, the longest distance that passes through the center is called the diameter, and the diameter is just 2 times the radius, so we can find out the radius pretty quick. All you have to do is really count the squares here. If you count them all, it goes from -5 all the way up to 9. If you add 9 plus 5, that entire diameter is going to be 14, which means the radius has to be half of that, which is 7. Now, for my equation that I want, okay, for the equation that I want, I actually want r squared. So let's take 7 times 7, or 7 squared, which is 49, and I'll underline that as one of the pieces that I'll use up here. Now, h and k are actually a little bit more tricky. I want to find the center of the circle, but where does it go through? The diameter always goes through the center, and when you think about it, if the whole diameter is 14, and it goes from end to end through the center, then the center has to be exactly 7 units away from the edge. So if I go 9 and I go 7 units down, okay, I find that the center is right here on 2. In fact, that center is at 2, 0. So I have h and I have k. h, k, r squared, we are ready to write the equation. X minus h squared plus y minus k squared is equal to r squared, or not r, remember it's 49. And we could simplify this one more step just by rewriting this term as y squared. And this is what I would type into delta math for problem number 2. Okay, problem number 3. We need a couple of things. Center at HK, and we'll record what that center is, and we'll also find out what R is. So that's my checklist here. 2 things that I need to get, the center and the radius. Just because I've done it every time, let's rewrite that equation one more time. And we can plug in all those parts. Okay, if we take a look at this circle, it looks like it has an even radius. It's pretty easy to just eyeball this one. You can see that this point is 3 units apart from all of the sides. So not only do I have a center at -7, -6. Okay, so my center is at -7, -6. Okay, and my radius is just 3, that 3 units of distance I found before. So R is going to be equal to 3. Remember, we want R squared, and that's 9. So we have all of our parts. H equals -7, K equals -6, and the radius squared equals 9. Those are the 3 parts I need. Let's write the equation. X minus -7 squared plus y minus -6 squared is equal to R squared, which is 9. Now you do not have to write it like this every time. If you just want to switch the sign and say it's X plus 7 and Y plus 6 right off the bat, that's easy for you to do. That's fine. I'm just trying to point out the delicacies here. X minus -7 is just X plus 7. And Y minus -6 is just Y plus 6. Okay. Now, before you go wasting all your attempts in delta math, how do I check my work? Well, if we take this equation, +7 plus 6 equals 9, and we go over to Desmos, let's open a new graph. Okay, I typed it right into Desmos. Make sure you use this little keyboard tool. Makes it really easy. And it matches what I had on my assignment. Well, let's confirm that. So here's my graph from the assignment. Here's me checking using Desmos. It's in the same place, has the center, has the same radius. So I know I'm correct there. Now that you've gotten this knowledge, it's time for you to go to Delta Math and try it out. If you have any issues signing on to Delta Math, let me know. Once again, if you want help on this assignment, I recommend you use the graph that I shared in the description below. Remember to subscribe. I'll keep posting videos up on here. Keep you posted. Other than that, I hope you guys have a good day. Do your best. Keep learning. Have an open mind. And take it easy.